Right. Let's fix the problem that the black king currently considers taking the rook an illegal move. Because the end result is that the king is at the same square as the rook. Hi, Amon. Okay, that worked. So we're entering king moves, or the black king moves for this board. And then, of course, the black king can move into the corner. That would be this one, which is stored at index 0. And the king can take the rook. That's the only other move. Well, that would be illegal because it's in check. And the white rook, it says, is on 2-1. 2-1. Well, that's true if you look at it like that. This is just printed flipped. Okay. And then it examines it by creating the board with the king on 0-0. And it creates a board with the king is on 2-1. Okay, nevertheless, it still says that this is made in 2-ply, because there is a possibility that it's made in 2-ply. The black king could go to the corner and then rook is made. But of course black would never do that. Black would take the rook. But, well, that's the same situation as... Let's see, we just move the rook all the way there and then to the next row. So ending with this position, or the black is mate again. Slightly confused that it's not saying adjacent here. I thought I had an adjacent. Oh no, I have an alternate. Maybe I should use a debug channel called adjacent. No. Yeah, with the king in the corner, of course, it can go nowhere. So you, that was the wrong position. I need this one. Let's see, the king is now here. What is that? It's an adjacent board. 2-ply. Made in 1. Sorry, I need a made in 1 position. Let's just scroll down till I see that. Made in 1 position where the black king is not in the corner. Yeah, I think the rook is just going to move over the whole board. I could make that a separate channel. A rook channel, because there's a lot of output. Okay, the rook is at the end of the board now, and the next one should be the one that I look for. No, now I get a mirrored position with the king still in the corner. Yeah, of course, indeed. Ouch. Okay, I have to go all the way again till the rook is in the corner. Now it's at 6, column 7, going down. Okay, now it's in the corner again, so now we should get... Yes. Well, no, actually. It's still in the corner. Oh, now we get with the white king was here. Now we get the position with the white kings. There. Oh my god, yes. And then the flipped one. I mean, that it really likes the black king in the corner. So we get all positions that are made in one. With the black king in the corner first. Okay, so that means I have to move the rook again to... Yeah, this is a bit too slow. I'll do it now, but need a better way to jump to the correct position. No. Yeah, no, my mistake. This is not working. Sorry, it's just bullshit. I'm looking for... I'm actually just looking for this position. Very at the beginning still. No, the rook must be on the third row. That's what I'm looking for. Moves till the end. But. Yeah, this position. Pretty sure I meant this one. So now it can find out that in order to get to this position, the black king could have been standing there and then played into the corner. And then white is to play, and then white can give mate in one. But the black king can also go there, which is then not mate. And that then it doesn't take the rook, so that makes more sense to. It's a more simplified thing, I think. So we should fix that first. So now I'm looking for adjacent board. I think I should turn the illegal channel off. So this is an adjacent board, and then from this position okay, what the fuck. It's adding this position to index 1. Oh yeah, okay. So it does conclude finally here that this is made in 2 ply. That the king goes into the corner and then we get mate. And this is not correct because it could also have gone there. Now this board was found by moving the black king from here to there. Backwards, basically. Go to the previous move. And then I should reject it, because if it moves back, we get a made in 1, but if it moves there, it's unknown. Didn't consider that yet. And well, then therefore it's not made in 1. Apply. How do I do that? This code is just generating it, and then returns it as member variable of the king's move. So put in this vector here. Turn illegal off again. I think maybe that's what I was missing. We also have another one called alternate. It gives more information. I wonder if we can just find that position by looking at the right coordinates. Or I can reconstruct it from my head. Ish. So it must be flipped, meaning I have to type that one first. And I want the rook to be at 1-3, I think. So this is 1-0 then. And then the king on 0-2. And the rook at 3-1. But then flipped, so not this one. That's the only one. What oh yeah, right. Sorry. Huh? No. Yeah, nonsense. But yeah, it's always stored in the canonical order. And I print it like that now, so canonical meaning that this one is less than or equal that one. And if you swap these, then the rest must be swapped as well, of course. Now that worked. We found this. So we are considering if black had a better move, or rather, what move black had in order to end up in the corner. and that is this board. And now we are trying to find out if black had a better move from this position. So we enter again king moves for the black king. And then from here it can move in the corner. And that is then called alternate. It's not alternate because it just does the actual, goes to the actual position. But alternate is that it could have gone over there. Yeah. So at the moment I print this thing, we should realize that it is actually something that should be rejected. Yep. I don't like the fact that every time I create a board I have to do these two lines. Maybe I'm going to add back this boolean to the constructor and then just call mirror inside constructor. If it is true. That way you cannot forget it, at least. I'll probably also construct boards without it, but okay. We'll see. Better to look for a mirror call. Pos mirror, print flipped. Pos mirror, that's something else. I think I got them all. Now the annoying thing is that canonicalize also calls mirror. It's a slightly, if it is not canonical, then this is the same as mirror, and canonicalize, then also flips the flipped thingy. Maybe we can just, maybe I should pause the boolean here. We can combine that. I think canonicalize is only called from the constructor anyway. Pretty much. Oh, I'm doing something wrong. What am I doing wrong then? It must be mirrored if mirror is true and canonical is also true. So it's actually, well, yeah, that worked, but this is easier to understand, I suppose. No, it's not true. The thing is already canonical. Yeah, the thing is already canonical, but mirror said, don't you want to mirror it? And the other way around. That is funny. You could mirror it. Same thing here. Or is that just too lame? No. Oops. And of course I copied it. Ouch. Goddammit. What did I do wrong? Oh, wait a minute. Yeah, now it's assertion port is canonical failed. And distance less. So I'm trying to add a non-canonical board to the map. Here. 61. Which means that board yeah. Canonicalize. Synodize. That's what I called it before. Now it's called canonicalize. Called a mirror might uncanonicalize the Black King. Totally. That's not good. These things suddenly become much more complicated. Oh, it is something else. nothing happens. And here the board is canonical with the blacking not on the main diagonal, and we do want to mirror it. So this means that we want to go to, well, the mirrored position, but basically we just want to set the flipped bit on then, right? Or toggle the flip bit. Board is canonical, the black king on the main diagonal. Now we do not want to mirror it. Yeah, that's an obvious do nothing again. The board is canonical with the blacking on the main diagonal. Again. And we do want to mirror it. Even this doesn't really shine a light on what to do. Here I was thinking, well, why am I doing all this ASCII art? It's kind of trivial probably. Now I'm starting to doubt again. So in this particular case, the flipped bit should be off. And here then, it should be off here and should be off here if it is on the main diagonal. So I don't have to touch it. But what if I get a board where the flipped is on? Kind of depends then, right? I mean, in that case I want to turn it off. That's part of sanitizing or making it canonical, I guess. So yeah, maybe I should just take that into account as well. So then it's not really canonical. Canonical means that the flip bit is correct and the coordinates of the king is on the main diagonal or the upper triangle. With flip bit only possibly on if it is in this part. If it's on the main diagonal, it must be off. Let's extend it. So black on the main diagonal. If the black is on the main diagonal, then we have just two cases, I think. So A. Let's add the flip bit as well. In this case, the flip bit must be false. And here it will still be false. Oh, wait a minute. True. the same as this one, right? Why is that the same thing? It's not the same thing, damn it. It is not the same thing. The board, check this one. I'm gonna check all of them. Let me just check this one. The board is canonical, which means the blacking is on the diagonal or here in this triangle, with the blacking on the main diagonal, so it is actually just on the main diagonal. But the flipped bit, maybe I should remove the whole fact that it is canonical. But I'm testing this by calling is canonical, which I think does not look at the flip bit. It just looks at the position. But I need to know if the king is on the main diagonal, so I might as well just check that instead of canonical. Okay, so the black king is on the main diagonal. The black king is on the main diagonal, but the flip bit is on, and we do want to mirror it. So mirroring is what is represented by the ASCII art, and then below it including that the black king is on the main diagonal. And the flip bit must be represented separately. So in this case it's true, which means that actually the coordinates stored are these coordinates. Which means that if I just flip the bit to false, then it isn't mirrored when printed, and then you have this representation. So I think this is the answer then. I do not want to mirror it, so the king stays here. Oh shit. Sorry. Not canonical means that the king is there, but this is false. Le voice. Where am I? In the chat of YouTube. Okay, it just got even more complicated. The other way around. It says canonical, sorry, not the other way around. You just first get all the lines in place, and then roughly the correct layout, and then I'll just check everything again. Okay, let's check it. So first of all, the board can be canonical or not canonical. Yeah, I think we have 3 possibilities for the blacking. So the blacking is in the small upper triangle, or it is on the main diagonal, or it is in the bottom triangle. Hi, Koto. And if it is, yeah, part 7 or 8, part 7, I think. If the blacking is not on the main diagonal, it can be canonical or non-canonical. So we have 1, 2, 3, 4, 5 possibilities. And then we have for each of those 5, you have the possibility we want to mirror it or we don't want to mirror it. So I would say we need 10 cases, and I only have 6 now, or 8. So what am I missing? Because I have... Oh, wait a minute. This counts double, I guess. So I should have 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, 11, 12. No, why? Okay. So ignoring if you want to mirror it or not, we have the possibility that the board is canonical with the black king not on the main diagonal. That's what I said. Then we have the possibility the black king is on the main diagonal. Oh, these the want to mirror and do not want to mirror duplicates, because then we talk about flip bit being on or off. So that's 12 then in total. So 6 without the mirroring, and you just have 2 when the king is up here, namely canonical, non-canonical, and 2 when it's here, also canonical, non-canonical. And but also 2 when it is on the main diagonal, namely it's always canonical then, but it's flip bit is set or not set. So that is 6 possibilities. And I group them by want to mirror and do not want to mirror. So yes, first we have what is canonical, black king not on the main diagonal, and we do not want to mirror it. And then the same thing, but we do want to mirror it. And here I have the black king is on the main diagonal and the flip bit is off, and we do not want to mirror it. And then here also off, but we do want to mirror it. And then we have the, it's just twice the V. That's why it's not highlighting. It's still not highlighting. The black king is on the main diagonal and the flipped bit is, why is it not highlighting? Oh, it says but instead of and. But the flip bit, so I can highlight that now, or should have 2 of these as well. Yep. So the black king is on the main diagonal, but the flip bit is on, and we do not want to mirror it. And the same thing, but we do want to mirror it. So there's 4 in total, a duplicate of a factor 2 because of the mirror, and then 2 because flip bit is on or off on the main diagonal. And then the board is not canonical and do not want to mirror it. And the board is canonical and we do, sorry, the board is not canonical and we do want to mirror it, and we do not want to mirror it, these 2. Okay, I'm kind of convinced that I have all the cases now and the right description. So now let's match the ASCII art against the description. The board is canonical, the black king not on the main diagonal. Well, the black king can be anywhere as long as it's not on the main diagonal, so it's either there or there. But it is canonical, meaning that if it's in the upper triangle, then this must be false, and if it's in the lower triangle, then this must be true. So let's just first look at the input. And the white stuff I just always put in column 3 for the input. You can check that immediately. The white, everything is in 3. Column 3 for the all inputs. Yep. Here we have the board is canonical with the black king not on the main diagonal. So now the same thing, it's either here or there, but now the booleans are exactly the other way around. Or not, wait a minute. No, it's the same thing, of course. It's canonical blocking, not on the main diagonal. Same thing. Just the output is different because you want to mirror it or not. So again, this one is false and this one is true. Then we get the blacking is on the main diagonal and the flip bit is off. That's on the main diagonal and this is off. Blacking is on the main diagonal, but the flip bit is on. So same thing, it's on the main diagonal, but now it's true. The blacking is on the main diagonal and the flip bit is off. Blacking is on the main diagonal, but the flip bit is on. So again, that one. The board is not canonical, blah blah blah. So not canonical means the king is either there or there, and then this one is wrong. So in this case, false belongs to that one and true to that one, yes. The board is not canonical, the same thing. So here with false and there with true, that is correct. And then we have to check these ASCII arts. That the output is always exactly the same as the input, I guess, except when you want to mirror it. So it depends on if you want to mirror it. Plus, it must be canonical. So first of all, we do not want to mirror it, therefore the position is the same here and there. And since the king is in the upper part, this must be false. Same here, nothing changed, and because the king is there, it must be true. We do want to mirror it, so now it is mirrored, correct. And it must be canonical, so because the king is in the lower triangle, this must be true. And then here as well, this is mirrored, and now because this is in the upper triangle, this must be false. We do not want to mirror it. It's the same position. And it's on the main diagonal, so this must be false. We do not want to mirror it, so the position is the same. Main diagonal, false. We do want to mirror it, so the position is mirrored now. Main diagonal, false. Do want to mirror it, so yep, that's mirrored, main diagonal, false. We do not want to mirror it, so the same position, this is a lower triangle, so this must be true. And same thing here, nothing, it's not mirrored, no, it's there, so it must be false. We do want to mirror it, so this is the mirrored position, yep, and it is in the upper triangle, so this must be false, and here it's in the also mirrored, and now it's in the lower triangle, so this must be true. So all ASCII art is now correct. So now we can check for the algorithm. In these two cases, because it's still two cases, even though I have called it only one, I had do nothing. Well, the board didn't change and the boolean didn't change here, and the board doesn't change and the boolean doesn't change, so that's correct. The board is canonical with the blacking. Oh, I don't have to read that anymore. Toggle the boolean. Yep. If you toggle the boolean, then the representation is flipped. So the coordinates, internal coordinates, do not have to be mirrored, but you have to flip this boolean. And it just is represented as a flip position. So this is correct. And here the same thing, the boolean changes and the position is mirrored. That's just toggling print flipped. And here it is false, false is false, and the position doesn't change, so do nothing. And here the boolean is flipped, but the position is not changed. So That means that, well, flipped is set to false, or must toggle it, but also must mirror the coordinates itself of the white pieces at the very least. And here we have position is flipped and the boolean is not, so we just need to mirror it. At least at the very least the white pieces. Here we have this must be flipped, and the position is then automatically mirrored, flipped basically, so we do not have to mirror the coordinates. Here I didn't fill it in yet. So this becomes, it is mirrored because of the flip, but the position is not mirrored, so we have to mirror everything. Yes, and that also holds for this position. This is toggled and that doesn't change, therefore it had to be mirrored. And then case 6. It's not toggled, but everything is mirrored. Where did I put it? Okay, I think I got them all now. That was for each special case the description of what has to be done, but the code is written differently. We have certain actions that we need or need not to take. So now I have to look for which actions exist, and I'm pretty sure that the actions that I already had are the correct ones. I just mirror everything and we flip. So this is one action and this is the other action. I don't think we have any other action, right? Therefore, talking about purely toggling, it's case 2 must be toggled. And 3b must be toggled. And 4b must be toggled. And 5 is toggled. and 6 is not. Eye contact. And the mirroring must happen 3B is mirrored, 4A is mirrored, 5 is mirrored, and 6 is mirrored. Now we can short circuit a few things. The board is not canonical and we do not want to mirror it, or we want to mirror it. In both cases you have to mirror it. That's confusing. That's confusing. Why? The difference between 5 and 6 is determined by this one, I guess. In 5 you also do the flip thing. Interesting. And here we have the blacking is on the main diagonal, and then the flip bit I don't give a shit. Actually I do, because okay, and the flip bit is equal to that we equal to mirror. Yes, this one is off and oh wait, we want to mirror it, so it's unequal. On and not want to mirror. So it's and print flipped. It's unequal mirror. Let's see, the border canonical lamp. Black king is on the main diagonal, but the flip bit is on. And we do not want to mirror it, or we want to mirror it, so that's don't care. No, it's too difficult, too different. And I can already check if it is canonical. What is missing here is knowing if the black king is on the main diagonal. Could make an on main diagonals in the black king, I guess. This is a, yeah, I mean, why not? So BK is the black king, and then we need a thingy for not just canonical, but on the main diagonal. Square is a struct, and I'll just access it directly. Yeah, it is a struct, so I can just access N and M directly. Might as well do that. Pos N equals pos M. Now, since directly after flipping it, I want to print the board. Actually, I want to maybe I want to print it if it is changed at all or not. Maybe just don't want to print it at all. Nah, maybe you should print it. Might as well print it always. Does it really make sense if we don't change it? So maybe just the board is now. Either then mirroring or flipping, just any change really. Let's do the actions thing. So I have a boolean. Flip. The board is canonical. The black king not on the main diagonal. So canonical and not PK on main diagonal. And we do want to mirror it. and mirror. Or this one, the blacking is on the main diagonal. But the flip bit is on. Or the board is not canonical and we do not want to mirror it. Not canonical and not mirror. Let me start some music again here. Right. Yeah, somehow I had expected this to collapse into something trivial, so I could say, "Ah, I'm so stupid, I could have seen that immediately." But now I'm thinking that it was actually necessary to make this analysis with all the drawings and everything. So I'll probably just leave the comment in. Because it doesn't really look trivial, does it? Am I missing something? If it is correct in the first place, of course. Kind of looks like an exclusive OR here on there. If you combine this with that, yeah, I don't know. Yeah, this is an exclusive OR, right? I mean, so this is set and that is set, or it's not set and not set. But that one only counts if this is false. Not trivial. Yeah, I did my very, very, very best to be accurate and not make any mistakes, but since it didn't collapse into something simple, I'm still not sure. Although maybe if I think about it a little bit longer, it is trivial. What do you think? Why do we have to mirror it regardless if it is not canonical? There must be some logic to that. Okay. I think that if we do not want to mirror it, aka mirror is false. No, it's just no. Man, there is no logic in this, really. So I doubt that I can test it in production code, really. I mean, I would have to run into something mysterious and then figure out that this function is wrong. Ouch. So let's just add a lot of asserts. And I should switch to capital asserts. No, I don't know anymore what I was editing. No, there. So the only thing I do know is that, at the end, this thing must fulfill certain conditions. Namely, if the king was on the main diagonal, it is still on the main diagonal. That's a kind of almost stupid to do, because it's definitely not going to be broken. If you want to test everything, then why not? So the call to bk is on main diagonal did not change. Furthermore, the thing must be canonical now. That's the whole idea, of course. Simply call this is canonical. Yep, and then the actual mirroring. So I have to compare mirror with an expression that tests if the position was mirrored, which is impossible if the white pieces are all on the main diagonal. But how do I test it? So the set of this is defined to 1. I can only test it if I remember what the previous coordinates were. Maybe it should just... Oh, the do mirror, of course. Huh? What? No. Wait a minute. Ah, it's easier than that. I mean, I know that it was mirrored if these two are unequal. Because then I mirror this. It's an actual mirror. Unless also that happens. Then it's not a mirror. Oh, but that reveals something. that reveals something big. That looks like a way easier method to calculate a do mirror. Isn't it? Yeah. So once you have one of these, you can do the other one. Very simple. I'm gonna test it first though. Like this. It didn't crash. So that's I sure did hold all the way up to there. Okay, so I guess it did works. Let's continue with finding that one position again. Right, so if any of these alternate positions are not in my map already, then the thing must be rejected. does it, sorry, does it print on? Yes. So here I just took the rook, which is also returned. Well, not returned actually, but at least printed. And I'm just not going to store it, so this position, if it is returned and it is not found in the map, never, then it's always assumed to be made in infinity, basically, and that's correct. That's the rule. I wonder what happens with stalemate, so didn't take that into account yet. I don't think I have to worry about stalemate, so I'm working backwards for a mate, so it's just never going to happen then. Is it? No, I don't think so. Okay, so here we have to look up the board that we just created in the map. See if it exists or not. So then I need to pass that map, I guess, to preceding positions. Let me commit what I have made now. We have three different things. What was the third thing? Oh ja, this. Wondering if this should be in the main function. Maybe it should have a different object. Some master object for everything. What should that object be called? Could just call it graph, I guess. Not clear yet how to do this. Guess it's the problem of graph that well, everything is the problem of graph. Could move whole main to it. It's even this. This could be part of the constructor. Then I don't have to pass positions to it here. Simply the default constructor constructs a graph with all the already made nodes. And then, hell, it could even immediately continue with filling it completely. Yeah. I don't think I have how to use that anymore. Let me just move this to the constructor. Okay, what happens? Oh, that happened. No, never mind. Mm-hmm. Right. I think I should just use a vector of maps. guess I could do it recursively, like if the map is empty, then this call itself is apply -1. Yeah, why not? Actually. I already answered Kotaro, who asked that 1 hour and 15 minutes ago. Yes, it is a test project. Made in. Apply. I'm getting tired of typing apply -1, but well. Positions does not exist. Let's create a new vector for that. They are different every time, so I might as well reconstruct it here. Yeah, why not? Okay, so this would retrieve all preceding positions where the only moves are leading to mate in apply -1. But it's the preceding moves. So, and the only moves lead to, well, actually depending on who is to move. The only moves for black, but at least one possible move for white. Therefore, these positions then that are here returned are made in apply. And then this just prints stuff going one deeper, but that's kind of nonsense now, isn't it? I already do that recursively. Yeah, anyway, I definitely do not want to do this. I have to do something though. Well, probably we have to add it to the map. Let's not do this yet. I have to pass this to preceding positions, where this is the map type. I don't think I can include graph here, can I? What's board.cxx, but well, we have to do that in board.h then. I think graph.h already includes board, so probably not going to work. Blah. I'm just going to no, that's nonsense. So if I already need this in board, then why do I need that in board, right? I could move it to board and blah blah blah, but it feels like it doesn't belong there. Is there a way around this? Well, the only way around it I can think of is if preceding moves is a member function of graph instead of board. Is that possible? Yeah, of course is that possible. Of course that is possible, and it's probably the right thing to do then. This is simply accessing, it is accessing board a lot, I have to admit that, but I think I'm also making copies of stuff, like here. I think it makes sense. Okay, let's move this function to graph then. Meaning it has to go from here. damn it. Really, it stands for current, of course. It's just the. Then we should even rename this thing to current board. But then I can hardly make this joke anymore. Duh. Tough decision. No, it's not a tough decision. I just have to rename it to current board. It's just the way it is. Uh-oh. No access for. Parenting. What is this for board? Kind of board. It's alternate board, alternate move board, or whatever. Aha, ja. No generate. It doesn't link. I don't need to pause that actually, or do I? Theoretically you would say I only have to call this, I should call this only once. And then it just builds up on the last thing that we have. So we can just look at the size of the vector. Yeah. Kind of actually, just not pause it. Hey, it's a vector. Ah. Apply. Just not data. This one. Interesting. Go undeclared. I was thinking it would say could not find the undeclared identifier found, not found. They disagree. Yeah. What? I just want to reject the adjacent board. So, what is going on? And where's my music? Nope, that's not music. No. Okay, so we have the current board. This is the previous position. Well, one of many. It's a loop. Now we loop over all the positions that we can reach from that previous position. That's called the alternate board. Alternate position. Maybe I should rename board to position. In the beginning I had a square called position. That's why I called board. So yeah, alternate position reads much better, huh? Doesn't it? So I run over all possible positions that are reachable from adjacent board. And if we find one that is not in my database yet, then black would do that. I mean, black is the move here because we just generated black moves. And then we set found to false, break out of this loop because I want to reject, yeah, this one. So I want to continue with the next move. Is that correct? Yeah. Oh, sorry. Yeah, I finally see it. I'm so got confused by this scope here, which is only for debugging purposes, for the indentation marker here. But yeah, we need this thing to be outside of that. Let's call it valid. So the test is in the correct place. Okay. Yeah, I think I can just go here. Pattern was found. It's even better. Gotta be kidding me. Made in 0 position. Entering king moves for board, that same board. Result, there was absolutely nowhere where the black king could have come from. What? Oh, the white king, sorry. This is weird. Yeah, I think this is for the white king. Yeah, it is. King moves white king. So the last move cannot have been a move of the king. And then we enter rook moves. And then we find this adjacent board. And this adjacent board. That's the next one. Is it not printing something then? Or do we first collect all adjacent boards and then print which are made? I suppose. Would be nice though to have very close that it gives us a thumbs up here. Yeah, so it prints all the adjacent boards and thinks they are okay, and now we are printing the result. So again the same position, but now with the text made in one position. And then we go to the next made in 0 position. It's all true. We just have to increase the ply 1 to run into more interesting stuff. So we should be able to do generate ply 2. Oh, really? Interesting. Trying to access data 1 while data has a size of 1. Yeah, because we never added to the map in the end. So the size is still 1. That should happen in generate. This just returns result, but it should also add it to the map. So these are boards that must be added to the next ply, which is then, I guess, to a newly created map, aka we have to do basically all the same as this, but then on slightly different. Like this. Let's just not return anything. I can get it from graph if I want to. And we never want to. It's a private function. So that's not anything. It's printing it here, but maybe I should not do that then. Maybe I should just print it from the caller. Yeah, okay, now I have two things. I should go to main. But I have something in my buffer here. Yeah, also. Let's jump to main and then... Oh, in main I want to do this actually. It's a whole different main. for the cert. I don't know. Did I miss something? Just try to compile it. Oh yeah, that. What? Oh, I copied it here. Yeah, never mind. The here it was correct, but now we are moving it. I moved it here. So we want to store the results in the map here using ply. This is the previous ply, right? So ply +1 then, but well, whatever. Just at the end of the vector. So I resize it to one bigger, and then store everything in the map, where map is map is just the back of the data, really. How the hell did I end up with data resize here? Why does this compile and the other one doesn't? Possible. What? Well, because I looked wrong at the error, compile error. The empty map. I need to not apply. Yeah, I'm just going to use ply +1. Let's choose data size. Nah. Before or after? there is no in-place big for a vector. My data is const. Oh. It's now non-const because at the end it updates data. Suppose that's where they invented auto for, but damn it. All this trouble and then still nothing changed. Exact same error. What? Applies to data is 1 data size, yes. So we can't even do that. What? Why? I mean, it should have crashed here already. Because I'm trying to access something that doesn't even exist. Empty is nonsense, indeed. I just should look at the size. And why does this not crash then? Oh, it does crash. That's exactly where it crashed. Okay, in that case, yeah, what I should do is test something with data size being less than ply, plus or minus 1. And I had ply is 2 while size is 1. Yay, that's correct. Let me see. No, this is correct. Size is 1. Ply is 1. That would be correct. And don't have to do anything. It should work. Thanks. It is using CPU and the memory is not growing. What is it doing? No stack overflow. Interesting. And now it's printing stuff. Oh, I guess it was doing that before as well. But yeah, for plies 2 it should have finished immediately. So this is kind of weird. And again, absolutely nobody understands what's going on here. This is not a mate in 0 position. It's, I don't know what it is. Right, so we are entering generate 2, which then says, hey, but you first have to call generate 1. So far, so good. Made in 0 position. Well, that's correct. Entering king moves. White, nothing possible. Entering rook moves. Shall we go to a board of 4x4? Because, yeah. Oh, things happen here. Looks very uninitialized. Okay, I think it's time to take a break. Totally take a break. I moved a lot of stuff to graph, breaking everything. Okay, good night, as it were. Maybe I'll be back, but probably not. I don't know.